Welcome to Daily Papers, the podcast where we break down the latest research into bite-sized, easy-to-digest pieces. Today, we're diving into a paper that feels a bit like a David versus Goliath story in the world of artificial intelligence.
It really does. We're all used to hearing about these gigantic AI models with billions and billions of parameters costing millions of dollars to train. They're the Goliaths. But this paper introduces a much smaller, nimbler system called B1ade that really punches above its weight.
The paper is titled Models for Minimalist RAG, which sounds a bit technical. Before we get to the minimalist part, can you break down what RAG even is for our listeners?
Absolutely. RAG stands for Retrieval Augmented Generation. The easiest way to think about it is like an open book exam for an AI. Before the AI answers your question, it gets to retrieve or look it up from a set of documents.
So it's not just relying on what it memorized during its training, it can access fresh, up-to-date information.
Exactly. The retrieval part is the AI acting like a super fast librarian, finding the most relevant paragraphs from a massive library. Then, the augmented generation part is the AI using those specific paragraphs to write or generate an answer. This makes the AI much more factual and way less likely to just make stuff up, which is a problem we call hallucination.
Okay, so RAG systems are like AIs with a built-in fact checker. But the paper says we need a minimalist version. Why? What's wrong with the big ones?
The problem is that state-of-the-art RAG systems usually rely on those giant Goliath models we mentioned. They require massive amounts of computer power, which is incredibly expensive. This limits who can build and use this powerful technology. You basically need the budget of a huge tech company. The goal of this paper is to create a high-performing RAG system that can run efficiently on much cheaper, more accessible hardware.
Enter B1ade, our David in this story. The paper says B1ade is an efficient RAG architecture with two main components. Let's take them one by one. What's the first part?
The first part is called B1ade Embed. This is the librarian, or the retriever. Its only job is to get really good at finding the right information when you ask a question. And the way the researchers built it is fascinatingly efficient.
How so? Did they spend months training it?
Not at all. This is the zero training part. Instead of building a new librarian from scratch, they took 5 existing pre-trained models that were already good at understanding language and just merged them. It's like creating a super librarian by combining the knowledge of a history expert, a science expert, and a literature expert, all without any extra classes.
So it's a Voltron of AI librarians. That sounds incredibly resource efficient. So that's B1ade Embed, the information retriever. What's the second component?
The second component is B1ade 1B. If B1ade Embed is the librarian, B1ade 1B is the writer. It's a language model whose job is to take the documents found by the librarian and craft a clear, accurate answer. And the 1B in its name stands for 1 billion parameters.
1 billion sounds like a lot, but in the world of large language models, that's actually quite small, isn't it?
It is. The biggest models are now in the hundreds of billions or even trillions, so B1ade 1B is definitely in the small language model category. The researchers trained it on a carefully curated dataset of questions and contexts using a method that's basically like giving the AI a reward every time it produces an answer that's highly similar to the correct one.
So we have an efficient librarian and a small but well-trained writer. But the paper's central finding, the really cool discovery, is something they call emergent attribution. What on earth is that?
This is the most exciting part of the paper. Attribution is just a fancy word for citing your sources. It's when the AI says something like, according to the document you provided, or passage 3 states that. It's a sign of a trustworthy AI.
Right, it's showing its work. So the researchers must have trained the AI to do this, right? Gave it extra rewards for citing sources?
That's what you'd think, but no, this is what makes it emergent. The researchers never told B1ade 1B to cite its sources. The reward was only for getting the answer right, but the model started citing sources all on its own. In fact, it ended up citing sources in 42% of its answers, which is 5.5 percentage points more than it even saw in its training data.
Wow, so the AI just figured it out? Why would it do that?
The theory is that the AI learned that citing its sources is an excellent strategy for maximizing its reward. It figured out that if it grounds its answer directly in the text it was given, it's far more likely to be accurate, and therefore more likely to get the reward. It's a complex, useful behavior that emerged naturally, just from the simple goal of being correct.
That's incredible. It's like it developed good academic habits on its own. So we have this clever, efficient system that has taught itself to be more trustworthy. How did it actually perform on the tests?
It did really well. The librarian, B1ade Embed, is a top performer for retrieval among models of its size, and the writer, B1ade is a beast. On a popular question answering benchmark, it achieved the highest score among all models in its class, even beating a model that's 50% larger.
So David really did beat Goliath, or at least a slightly bigger Goliath.
Exactly. And when they put the two parts together to form the full RAG system, it was highly competitive. It especially excelled on a metric called faithfulness, which, as you might guess, measures how well the model sticks to the facts from the provided source documents. That emergent attribution really paid off.
So what's the big takeaway from all this? Why is this paper so important?
It shows us two really important things. First, you don't always need gigantic, resource-hungry models to get great performance. With smart design, like merging models and targeted training, we can build efficient and powerful AI that's accessible to more people.
And the second thing?
The second, and maybe more profound takeaway, is about emergent behavior. It suggests we can create more reliable and trustworthy AI systems without having to handcraft every single rule. By simply rewarding an AI for being accurate, it can learn sophisticated strategies like citing its sources, all by itself. It's a huge step towards building AI that is not only smart, but also transparent and grounded in fact.
A smaller, cheaper, and more trustworthy AI. It sounds like a win-win-win. That's all the time we have for today. Thanks for tuning in to Daily Papers.